Hello, class. This will be the recorded lecture starting in Chapter 8. This is Section 8.1. I'd like to end the college algebra curriculum talking about these concepts of how to solve a system of linear equations. And basically show you the technique that is used and basically how a computer would solve it. And in this digital age that we live in, I think it's very important to kind of understand that kind of process and how it relates to your math curriculum that we are teaching you. And for those of you heading into any type of computer programming, this will give you a feel for what you might expect moving into that. So we'd like to start by solving equations like human beings do. And we're going to start with two equations and two unknowns, and all the equations are linear. And so we're going to move up to three equations and three unknowns, and then we're going to stop there. Computers will do hundreds of variables, and they don't care, but it starts to get very tedious really quick. So I think three would be the good place to stop. So before we do that, let's start by talking about the possible solution set for two equations and two unknowns. And so this, we would be using the XY variable that we're very familiar with. Again, remember everything is linear, so both lines are straight lines. And the idea is we have three possibilities. Possibility number one, you have a single solution, and that's the most interesting one in most cases. And this is the idea where you have two lines that will intersect, and right where they intersect, that'll be your solution set. Recommend using Desmos to check your work or some sort of graphing utility. The math book and many math books call the second idea of no solution something that they call inconsistent. I always use the term no solution. And this is when two lines are parallel, i.e. they never intersect, right? The definition of parallel lines. And so when you walk through the algebra in this case, you'll find that you would get a solution like 6 equals 8. Can't happen, right? And so that's what we mean by no solution. And then the last one is the least interesting, where you have two lines and they're both the same line. They might be configured a little bit different, but once you solve them, you'll see you get 3 equals 3, right? Always occurs. So any x and y value of the first equation matches the second equation, and it's basically the same line. So with that, we're going to start by introducing this idea of solving two equations and two unknowns the way human beings do, and we call this substitution. So let me show you how that works here with an example. So we have 5x minus y equals 5, and 4x minus y equals 3. So how do we solve this using substitution? Well, the strategy is this. What you want to do is you take one equation and solve for a variable. Let's solve for equation 1 here. Let's solve for y. And so what we'll do is we'll take 5x and say, let's move the minus y to the other side. So we get y plus 5. And then we'll bring the 5 to the other side, and you get y equals 5x minus 5. Say, okay, so now we know that y equals this expression. We can plug it back into the second equation and get rid of the y by putting in 5x minus 5. And now we have one equation and one unknown. So we distribute the minus through. Minus 5x plus 5 equals 3. This would be minus x combined in those terms. Bringing the 5 to the other side, you get minus 2. And then if you multiply each side by minus 1, you would get x equals 2. So what's y? Well, if we plug it back into that equation, or the other one, either one. But this one's set up nice, right? So we'll just use this. And you see this would be 10 minus 5, and so y would equal 5. And sometimes we put it in the ordered pair form, x equals 2, y equals 5. So when you take a look at this, you should graph these in the sense that it's a good way to check your work. And what I mean by that is use technology to help you. So let me, I did this already, but I pulled up Desmos and I typed in those two equations. And as you can see, where the red and the blue intersect is x equals 2, y equals 5. So it's always a kind of a good way for a way to check your work. So hopefully everybody was familiar with that and that technique. And so the technique we are going to introduce is this idea of elimination. So what do we mean by elimination? Well, basically what we're trying to do now is a step-by-step process of eliminating certain variables from each one of the equations so we can get to a point where we have x equals something and then y equals something. And again, this is kind of how the computer will solve these problems and how they're typically programmed. So that's a good way to think about it. So here are the three kind of rules, or actually things that you could do to the equations. First one is you can interchange any of those equations. So if we have equation 1, equation 2, you want to flip them? No problem, right? The other thing is that you can multiply or divide, but typically we're going to multiply an equation by any number except for 0, right? And that equation doesn't change. And then here's the kind of the new thing, and the idea that you could take and either add or subtract, and we're going to be adding any two equations. And then that new equation could be replaced, can replace one of those equations. And you can see that these three steps could be used over and over and over again to solve a set of, or a system it's typically called, of linear equations. So let me show you this here up on the whiteboard. And we're going to start with two equations and then work our way up to 3. So let's do this one here. So say like we had equation 1, and that would be six x plus 2y equals 4. And say like we had equation 2 equals 10x plus 7y equals 8. And so the strategy is, especially with just two of them, is we're trying to multiply these equations by some number. And typically a integer is ideal because most people don't like to deal with fractions, right? So that when we add these two equations together, one of the variable goes away. And so what I'm going to do is eliminate the x variable. So what I'm going to do here is that I could, for example, multiply the equation 1 by 5. And so that would give me, so if we just take this whole equation and multiply it by 5, it would give me 30x, and then 2 times 5 is 10, so that would be 20y, and 4 times 5 is 20, and that would equal 20. So I want this second one here to be minus 30x, so I add these together and cancels out the x. That's the strategy. So what I will do here is multiply this by minus 3. So if I do that, that would be minus 30x minus 21y equals 24. So now if we add these two equations together, you could see the strategy here. These would cancel, and you would get minus 11y equals 44. So now one equation, one unknown, right? We could solve for y. Divide each side by 11. And you would get y equals -4. All right, how do we get x? Well, this is something called back substitution. We've never used that term, but basically once you have one variable, you can plug it back into one of these equations and get the other one. I'm going to pick the first one just because the numbers are a little smaller. So this would be 6x plus 2, and then y is -4 equals 4. So that would be 6x minus 8 equals 4. 6x, and you bring the -8 over, you would get 12. Divide each side by 6, and you see it's set up quite nicely, x equals 2. So in the ordered pair form, x equals 2, y equals -4. So that gives you a feel for the elimination technique. Let's do one more example to walk through. So here's the second example we're going to walk through. And I put the equation up on the whiteboard already. And so let's get rid of the y variables this time instead of the x, just to show you that you could go either way. And so in this case, if I take equation 1 and multiply it by -2, that's going to give me 6y here. And 6y and -6y will cancel out. So let's see what that gives us. So we'd get -2x plus 6y, right? And that would equal -2 and -9 would be +18. And so this here would be 2x minus 6y equals 3. So if you look here, the y's cancel just like we wanted. This would be 21. What happens to the x's? They also cancel. So 0 equals 21. That makes no sense, right? That's impossible. So what is this? This is that idea of inconsistent. Here, I would prefer no solution, but you'll see in my math lab, they'll say inconsistent. But what's more important is what kind of lines are these? These are parallel lines. And so what I did here was popped it up on Desmos. That's why I put the recording on pause for a little bit. And you can see that if you type in those two equations, the red and the blue are obviously parallel to one another. Not obviously, but they are. Same slope, different y-intercept. And you could see that if you looked at this line, they would never intersect. That's why there is no solution. So that ends the first of the recorded lectures for this section. The next recorded lecture, we're going to introduce 3 variables. So we're going to have 3 equations and 3 unknowns and walk through the elimination technique again.